All right, we are in knowledge check 4.5.1. All right, once again, it asks us to go ahead and create that vector of weight. We've seen this several times now. So I'm going to go ahead and create a vector of weight, use the concatenate function to do so, and I'm going to go ahead and include these weights. All right, so we now have a vector of weights. So the next one is identify functions that will compute the minimum and maximum values in this vector. So if you did some digging around, also if you just read the class material for this week, you would have found that there are functions called min and max. So I can go ahead and I can do the minimum, and that will provide the minimum weight in my vector. And I can do max, and that'll give us the maximum weight. So we see that the minimum weight is 70 pounds and the maximum weight is 101. Now next asks, what is the mean, median, and standard deviation of child weights? Well, we've got built-in functions mean, so we can run that on weight. We see that our average weight is 87.9. We can go ahead and look at the median. So the median weight is 90.5. And then we can get the standard deviation. Standard deviation is just SD is a function for that. And if we look at that, we can see that our standard deviation is just a little bit over 10 pounds. All right, the last one is apply the summary function on the weight vector, and what does this return? So let's go ahead and take a look at the summary. What this actually returns is several bits of information. You can see that we get our min, we get our max value, we also get our median and our mean, and then also gives us the first and third quantile. So this is actually pretty handy. Later on we'll see how we can make box plots, and that will be a visual representation of pretty much what we see here. But for right now, this allows you to kind of understand basically the range and a little bit about the distribution of a vector of values.